So, hi everyone. Today I will walk you through our project Skyhook. Uh, so uh, it's we use Skyhook with the IRIS-HEP tools like Coffee and and ServiceX with the main purpose of providing fast data queries by offloading computation from client to storage. Uh, okay. Skyhook is the current version of Skyhook is built on Ceph, which is a uh, petabyte scale distributed storage system. So I will just walk you through Ceph very quickly. Ceph is at its core it is a object storage system, and it has three types of interface for users. One is a file system interface, a POSIX interface. One is a S3 like object storage interface, and another is a block device interface. Ceph is unique on its own as it has no central point of failure. So there is like no single manager node that every reader or writer needs to contact before doing IO from Ceph. So every client can interact with the Ceph nodes directly, and they do not have a central point of communication. So it's it does not have any central point of failure. Also, one of the most important features of Ceph is that it's the object storage layer of Ceph is highly extensible. So it provides a software development kit for developers to build plugins and embed plugins inside Ceph uh, so that people can embed like user defined functions in the IO path of Ceph. In that way, you can like embed uh, custom functionality inside the storage layer, inside the object storage layer, and modify objects or access objects according to your application needs. So that's one of the most important features that we leverage while building Skyhook. So that's about the storage, like that's about the storage system that we use underneath for Skyhook. Since Skyhook is a data management system, we also need a data access library for doing queries. So for that, we use a framework called Apache Arrow. So Apache Arrow is in general like it started as a columnar memory format for high speed data access and efficient operations. Uh, so the way Apache Arrow is unique is that it allows zero copy sharing of data between different systems. So when you have like different systems working together in your ETL pipeline, for example, let's have Spark, MySQL, Pandas, each of them has their own in-memory format, and when sharing data between these different systems, you need to multiple times convert the data format from one systems to another systems, and that is not acceptable in when you want to do like highly efficient data analysis. So what Arrow does is that it defines uh, like a system agnostic data format that every data management system out there can understand, and so they can basically use a shared memory region and do not need to copy the same memory multiple times in their own proprietary format. So Apache Arrow, apart from this, so Apache Arrow started as this project like a columnar memory format, language independent columnar memory format for zero copy data exchange, but it then grew into a complete framework of data analytics components. So for example, it has like a dataset API that Carlos just talked about, which is an API to abstract over a set of files and apply SQL like queries over it, like filters and projections, aggregations over the dataset. Also, it has like a binary protocol for sharing data, a RPC based binary protocol for sharing data between different systems without much overhead. So yeah, things like that. I will jump into Skyhook now. So Skyhook is a programmable storage system. On a high level, Skyhook is a programmable storage system to offload selections and projections to the storage layer. So in general, what happens is that when you're working with a storage system, you first like read all the data into your client into your client machine, and then you apply your data analytics operators on it to like filter the data or whatever. That works, but when you have like thin networks and limited CPU and limited network bandwidth, then moving all the data, even though you don't need all of that, results in a lot of overhead that you don't necessarily need to have. What we do in Skyhook, like which is like the basics of computational storage system, that we reduce the data movement by moving computation closer towards the data. So selections and projections operations are applied inside the storage layer, and only the data of interest is moved across the network to the client. Also, when you are like working from a laptop, you have limited CPU on your end. But if you offload the same if you offload the same computation to a cluster of nodes, to a cluster of storage systems or storage nodes, then you suddenly have access to like a scalable to a scalable cluster, and that's where your CPU limitation is gone. So this is what Skyhook does on a high level, but Skyhook differentiates from other computational storage systems in the way that it is built and the ease of use that it provides to the users. So for developing Skyhook, we do not change even a single line in Ceph, and neither in Apache Arrow. So it's totally pluggable. It's built in a totally pluggable and embeddable architecture. So what you need, how Skyhook is installed or like is built, is that you have a Ceph installation, and to enable Skyhook there, you just have to like build the Skyhook libraries, the shared libraries, and you just need to copy it to the correct locations, like to the correct library locations in your system, and Ceph instantly picks up the plugin, and you can instantly start offloading queries to Ceph. Let me talk about the architecture a little bit. So on the right side is the storage layer of Skyhook. So there is at the very bottom is the object store. The main Rados object store of Ceph, which has like two parts. One is like the chunk store, which just serves data blobs, and there's a key value store for like storing and serving metadata. We embed as you can see, like the orange boxer, we embed Arrow shared libraries inside the Ceph object store using the Ceph object class SDK that I just talked about. So how it works is that in general, since Arrow libraries are developed for working on files stored in a file system, we need to add a new layer like a file system shim, so that the Arrow libraries can now work with chunks or data blobs. So we have a file system shim over the object store, which provides file-like views of objects to Arrow, and that we plug in that file system shim into Arrow. So in that way, Arrow can see files, like Arrow can access the objects, but as regular files. So in that way, we can like intelligently embed Arrow and still keep it working on files, although in real life it's working on objects. On the left hand side is the client side. So on the client side, for writing files into Skyhook, we do not have a special path. We just need to dump parquet files or whatever format Arrow supports. We just need to dump those files into a SafeFS mount. In the and that's it. The files are like written to Skyhook. So that happens through the POSIX file system interface SafeFS. Now, while reading or while querying the files, we entirely bypass the SafeFS interface because we need some way to invoke the functions that we embed inside the object store, and SafeFS does not allow us to do that. So we instead use one layer beneath SafeFS, which is LibreDOS, which is a library of which is like a client library of Safe that allows invoking the embedded functions in Safe. So during the read path, we still have the file system where files are written. So we, as a user on the client, we just know of files. So when we say Arrow, when we say Skyhook that go and scan this file, what Skyhook does is that internally it uses file system metadata and translates a file name to an object ID. And then once it gets the object ID, it invokes the embedded function on that object ID, and that embedded function has the query logic inside it. So the query happens on the object, and the resultant data is returned back in Arrow IPC format. And this entire client side interface is coordinated through the Arrow dataset API. Yeah, so that's about the architecture of the client and server side of Skyhook. So that's just the core of Skyhook, but to make it applicable to different areas of computer science, we integrate it with we integrate with other data management systems. So till now we have like integrated Skyhook with Dask. So by the time more and more popular data management or distributed compute frameworks are supporting the Arrow dataset API to read and write files. So not read and write, like to scan files containing tabular data. So we leverage that we leverage that dataset API adoption by other systems to make them use with Skyhook. So basically, we have integrated Skyhook with Dask and Coffee. So Dask is a parallel computing framework similar to Spark but in Python. So we can offload data frame operations from Dask, like Dask data frame operations into the storage layer of Ceph. And also in Coffee, we can offload high energy physics analysis operations, like common operations such as cut and zip, which is like synonyms of filter and projection on nano events in HEP data analytics. And we are also like exploring other use cases of integrating Skyhook so that we can like accelerate data querying, data scans. So where does Skyhook fit in this in the analysis, in the high energy physics analysis facility? How does it help us? So this is a slide that I took from Carl's slides from his earlier talk. So as you can see, this is like the entire analysis facility architecture. There is like Dask clusters, or Dask workers for doing the compute, ServiceX for delivering the data, and Jupyter Hub for users. Users are physicists doing the analysis. So you can see Skyhook here in the middle. So how it helps is that so ServiceX delivers a lot of files containing nano events and all the high energy physics data. So what we do is that we ingest the data from ServiceX into Skyhook, and then the Dask workers and the entire compute cluster accesses the data from Skyhook. So this is because we want to make use of Skyhook as a fast cache. So if you don't need, like, if your analysis operations have a lot of data filtering going on, then Skyhook makes a lot of sense, because you don't want to slow down your analysis by just reading all the unnecessary data into your client machine and run out of memory and all those issues. So we fit in Skyhook between the data delivery service and the Dask worker, so that users can get only the filtered data out, and also in that way accelerate their analysis. So it's a nice it's a nice and fast staging area for your data. Okay. Yeah, so I think that was mostly what I wanted to talk about Skyhook today. Now I will move to giving you guys a demo of how it looks in real life. So okay, I will change my screen share. Let's see. Sorry, 1 second. Okay. Yeah, so I have a notebook here showing how we can use Skyhook standalone and also with ServiceX and Coffee. So since Skyhook is exposed through Arrow, we have imported like the Arrow libraries. Then first is this cell here shows how to use Skyhook standalone. So Arrow dataset API accepts a format argument, which is in general a Parquet file format, which is like just a format abstraction to read Parquet files from local disks, or also from S3. So in order to expose Skyhook, what we have done, we have added a new file format to the Arrow dataset API. It's called the Skyhook file format, that under the hood uses Parquet, but also accepts information about a Skyhook cluster, so that it can internally during the read path can connect and offload operations to the storage node. Yeah, so basically, if you to make this work, you need to know your safe configurations, and that's it. You just have to replace format from Parquet to Skyhook file format, and you can instantly offload like filters and projections aggregations to Skyhook. So that's how Skyhook works standalone. But how would it look like for a physicist working like for an end-to-end data pipeline? So here we have a list of root files that you want to run your analysis on. So how it works, how it would work normally is that, so Skyhook works on Parquet files and LZ4 IPC files, but not on root files. So the first step is to ingest data into Skyhook as Parquet from your data delivery service, ServiceX. So here you have to like mention the result destination, that it would go into the SafeFS mount. So in this way, if you run this, then ServiceX will ingest data from Skyhook. I mean, sorry, Skyhook will ingest data from ServiceX as Parquet files. So there are transformers inside ServiceX that will convert the root files into Parquet files, and also select the optionally select the columns that you want to run your analysis on, and at the end it will dump the Parquet files into a SafeFS mount. So now your data is ingested as Parquet into Skyhook. It's now ready for your analysis. So we initiate a Dask cluster here. So we have also added, like just as I talked, we have added support for Skyhook inside Dask. So you can, so if you have like Dask functions like this, like Dask statements like this, you can easily offload filters into like Dask data frame filters into Skyhook. So your analysis code might contain a lot of statements like Dask operations like this. So it's very easy to offload. You have to just mention format equals to Skyhook again instead of format equals to Parquet. Now for this benchmark, like now for this demo, I will like show you how Skyhook works with Coffea, the Coffea processor, the Coffea processing tool. So there is a processor that takes in nano events and applies some analysis operations on the nano events. In Coffee, in general, what we do is that we mention our data set, like for example, like I have provided the path to a SafeFS mount, and we initiate an executor, provide the schema, and also mention the format in which the data is in. And in that way, the analysis runs on your client. But to instantly offload much of the compute to Skyhook, what we can do is that we can just provide a single flag to Coffee and say use Skyhook equals to true, and everything remains exactly the same. When you do this, internally all the cuts and zip operations, the filters and projections are offloaded to the storage layer. And ideally you should get a benefit on your on your like processing latency or query latency. So as you can see, like everywhere it's just a single line, or not even a line, like a single flag change, and you can start offloading to Skyhook instantly. So you don't need to, so basically you don't need to change all your analysis code that we have written over the years. You just need to just tweak a single flag, and that's how easy it is to like accelerate your queries and save bandwidth and scale out your queries. So yeah, so I think that's all what I wanted to show you all today. Let me know if you have any questions.
Thank you very much, Jayjeet. Great to see a bit of well, the theory and the concept behind Skyhook, and also seeing it in action here in this demonstration. We have one by Ben. Ben, would you like to ask it directly?
Sure. I was just trying to understand what I was seeing there. I'd originally thought that Skyhook would be doing like SQL selects, so basically refiltering the results that came out of ServiceX. But are you showing that the entire Coffee processor is running inside the storage layer? So if I'm doing histogram filling and all of that, is that running inside the storage layer?
No. So Coffee processors internally have cut and zip operations and other data frame operations to work like to process nano events. So what we do is that we try to detect those operations and selectively offload those to Skyhook, not the entire coffee code.
Okay, great.
The processor code, yeah.
Thank you. If there's other questions, feel free to write in the chat or raise your hands as well here directly on Zoom. There's one question I had, and I think you partially answered it in the demonstration here when you were talking about root files and how you have to convert them first to use this. Because I was wondering, I mean, this concept in general seems amazing, because all the time we're trying to read some remote data and we probably care about some small fraction of it and we want to apply some filter, but we then apply this filter typically wherever we're going to be running if we have some data on the grid and then we're running somewhere else over it. So all this sort of offloading would be great, I think, for all kinds of stages of analysis. So is this root to Parquet conversion sort of the main issue? Or if I now wanted to just have Skyhook everywhere, are there some other issues that ultimately don't make this the right solution for every kind of application? I'm a bit curious about sort of what potential things I might have to keep in mind when trying to use it everywhere.
Yeah, sure. So yeah, as you brought up the issue of converting from root, which is a HEP native format, to Parquet, which is a generic data management format. So that might be an overhead. That might be overhead for some people, but it's only a matter of time till Arrow starts supporting root format. Then that conversion can be skipped. Then you can then we can directly operate on root files, because since we directly embed Arrow, any day Arrow starts supporting a new format, instantly Skyhook have access to that new format. So yeah, but for now I think you have to there is no way other than converting from root to Parquet. Also another small limitation is that since we are working on the safe storage platform, the size of a particular file is bounded. Currently it's bounded to 128 megabytes. So if you have files larger than that, and obviously you might have files larger than that, you have to split it into smaller files. So if you have 1 million rows, you can and a 200 MB file, you have to split it into 500,000 rows, 2 files of 500,000 rows and 100 MB files, and then ingest that into Skyhook. So yeah, that's I think the big limitations right now.
Okay, thanks a lot. We have another question from Nick. Nick, would you like to ask the question, or otherwise I'll read it?
Yeah, can you hear me okay?
Yes.
Okay, great. Yeah, so along the lines of what you were saying before, what are what's the rule of thumb for what Skyhook can offload to the storage layer by presumably scanning the coffee code that you're going to run and looking for parsing?
Sure. So initially when we developed Skyhook, okay, let me start by saying our compute layer is totally dependent on what Apache Arrow provides. So the functions that Apache Arrow, the data management functions like filters and projections, aggregations, whatever Apache Arrow provides us is available for offload inside Skyhook. So initially when we developed Skyhook, we only have filter and projection operations to be offloaded, since Arrow only allowed those two, the Arrow dataset API only allowed those two functions to the Arrow dataset API exposed only those two functions to the users. But currently, if you follow the Apache Arrow developments, then you will see they have supported executing arbitrary query plans containing much more variety of operations like aggregations and sorts and string searches, things like that, more complex operations than just mere filter and projections. So as Apache Arrow is providing support for executing more and more various kinds of operations, Skyhook will also keep on adapting those features and can become can offload, can start offloading more and more operations inside Ceph. So yeah, so it's just a matter of time how Apache Arrow evolves, and Skyhook will follow along.
Okay, thanks.
Maybe one last point that Jim was wondering about, and then we'll go into a break. You mentioned that there might be support directly for root upcoming in the future. Is there some kind of schedule for this, or some estimate of how one might go about this? Is it just a matter of person power and time, or?
I was wondering what was meant by it, actually.
All right. Sorry for misinterpreting.
No, I am just at this point, I'm just hoping that the Arrow community adopts more and more formats, and not only popular data management formats like Parquet or Org or CSV, but like support for other formats like root, HDF5. So, and if they do not, we can also chime in and contribute support for reading these formats ourselves. So that's what I meant, that as Apache Arrow supports these new formats, that also becomes available upstream inside Skyhook. So irrespective of who does that, it needs to happen. So yeah, that's it.
It's possible that Apache Arrow might support HDF5, but almost certainly will never support root. I think we shouldn't be waiting for that, but we can use some of our tools such as uproot or our data frame in order to populate Arrow buffers, but they won't do it.
Okay, yeah, then I think then I think we have to live with Parquet only, because Arrow is very efficient. We cannot definitely ignore that. So we don't have any option other than to go through a little bit of conversion over it.
Okay, thanks. Thanks for clarifying this. Lucas, was your point also related to this?
Yeah, it was also a bit related, maybe also towards the support for kind of Atlas type formats, which we have in root. So we have experience in converting Atlas formats, which are in root files, into a Parquet, and that mostly works, but there are a few edge cases that don't work, where you have especially nested containers or list of lists or something like that, where you don't have any keys in between. And so that seemed to break Parquet to some extent, and we had to have some workarounds. Do you have some kind of benchmark files that you use to do to test this root to Parquet support? Otherwise, we could maybe provide some.
Yeah, that will be great if you can provide your files. I have done uproot to Parquet conversion before, and I agree it's not the easiest thing in the world. So, but at least to some extent it works. So yeah, please feel free to send me your files, and I will check if that can be easily converted. Or otherwise, if it's really difficult, then I guess maybe we have to split the root files based on a node, and so that to reduce the nesting of it a little bit by splitting, and then create multiple Parquet files out of that. So yeah, I mean, we can figure out some way probably.
Okay, yeah, I see Ben is commenting that ServiceX is kind of maybe a component. So I agree, ServiceX as a middle layer could work, but of course, if you could basically directly read it from disk as a root file into Parquet or Arrow, I think maybe then you don't need that extra layer. But yeah, okay, thanks.
Thanks, everyone. I'll cut off the discussion here. Let's follow up on this topic after the meeting offline, because this does sound like quite an interesting avenue to talk about a bit more. Sorry for running a bit late into this break. So what we're going to do now, thanks again, Jayjeet, for your talk, for the presentation here and for the demonstration.
Thank you.
And also Carl for the Coffee Casa presentation. What we're doing now is we're going into a break, and we're going to extend the break by 5 minutes. So we'll meet again in exactly 10 minutes from now to continue with the next session on user experience. We'll get the schedule updated in a second so that it reflects the new schedule. So yeah, we'll be back here in 10 minutes. See you then.
Hi, Ben, Lucas, are you still here?
Yeah. Do we need to log off?
No. I'm just asking because I want to find out what you mean. Ben, what did you mean about dreaming on, that you can't upgrade Arrow? And Lucas, if you have workarounds for Parquet structures that Arrow does not support, the support has been increasing. It's noticeable when we get into higher versions of Arrow. Things that didn't work start working.
Okay.
Also, a lot of them have been my Jira tickets.
Okay. Yeah. I mean, so I'm trying to remember, or I might be misremembering. So what we've done is we have our own kind of Atlas and the version of Nano AOD, which is FizzLite.
Yeah.
And so what we managed to do is to basically convert the full run-to data of FizzLite into Parquet. And then one thing we've also tried is to basically import that into BigQuery in Google, if you remember. And so there are like multiple workarounds. So I think there are like a few workarounds to just map FizzLite into Parquet. And then also, even though kind of Google BigQuery advertises that it can natively ingest any Parquet format, it's also not true. And I think we had to have some workarounds in order to kind of, placate Google BigQuery.
For BigQuery, was it a matter of doing the compliant nested lists where the structure inside is called element instead of being called item?
Yeah, it's something like that, or I think it couldn't do like a raw nested list. It had to have go through like something that had like a key. So it could do like a list of dictionaries of lists of, and so on. And maybe we had to like introduce like a dummy key or something like that. Yeah, so there are some limitations. I don't actually fully remember what the issue was, but I can try to find out again.
No, it sounds like it's probably this one. In all of the Parquet that Arrow creates without setting a flag, it uses a different convention than what Parquet has decided is the correct convention, and BigQuery uses that. Okay, but that's not a workaround, that's a flag.
Okay, sounds good.
All right, just checking because there were problems early on, and I wanted to see if if you had workarounds, a lot of them could be, if they were painful workarounds, a lot of them could be removed. You just go to higher versions of Arrow.
I see. Yeah, I'm curious. So I don't know. Do you know already today, after this session, which session you'll join? Will you join the CMS session?
I hadn't thought about it.
Sorry?
I hadn't thought about it.
Okay. Because we're planning to kind of continue this discussion after we invited you. We're basically in Atlas trying to kickstart some new effort, and there's going to be, I mean, basically the Atlas session will be some raw discussion, and I don't know if you would like to join. I think, you know.
Sure.
Yeah.
Sure, I'll go there because I already know what's going on in CMS.
Okay, great.
I'm scanning the slides.
Actually, on the topic of FizzLite to Parquet, it's slightly unrelated, but I was actually running it. I was actually not quite clear on how you would map the tree branch structure into Parquet and still benefit from partitioning and tools that would allow you to sort of lazily load and parallelize. Is that something that you've addressed in transferring Atlas data into Parquet?
Sorry, you're breaking up for me a bit. Can you repeat the last thing?
I mean, with Parquet, then I can't quite see how you would be able to implement sort of a tree branch structure and still maintain the sort of useful features of partitioning that you can get in Parquet when you reread these files. I don't know, I might have been doing something slightly different, but when I have to sort of put two trees together with branches that are of different lengths into Parquet, then I sort of lose the functionality of partitioning, because I have to sort of zip them into a new axis and to be able to put them in Parquet. Is that something you've worked around?
So this is so I think we normalized every file that we have has the same branches, and then if they're empty, they're empty. But so are you saying like variable size contents are an issue, or if it's just like the overall tree structure of different trees is different?
The overall tree structure of different trees would be different, right? So if you have sort of a nominal tree, which is typical in Atlas, and another tree which carries some metadata,
right.
How would you save both into Parquet without having to generate a new axis?
Yeah, so this is not something we looked into. So what we've done is to basically take like the first slide as we have, which is like a static schema, and convert that into Parquet. And that's like a fixed, but then you might have maybe some accidental variability, just if you have multiple files where maybe some file didn't manage to create like a specific branch because it didn't encounter an event that needed it. And so I think at that point we normalized, but generally we kind of think of FistLight as having a fixed schema. I agree, if you have events that or multiple trees that have different types of branches, maybe it gets more complicated, but I'm hoping that this is not like a typical use case that we would need to support.
Actually, I don't understand why there would be any problem.
Yeah, I'm having the same question.
Yeah, like I can see if data structures that have internal links, like if it's not tree-like, if it doesn't have a tree structure but has a general graph structure, then that's not natively implementable in Parquet. But for any tree structure, I don't know what the difficulty might be, including partitioning, because
maybe what gives us a clue here is the fact that Mohammed was talking about metadata. So were you particularly talking about the case where you have like metadata that's based in Lumi section number or run number or something like that, and you want to join that with the event data?
In a way, yes, but maybe my question was too biased with my workflow, where I sort of read in the files with Uproot and I dump them into Awkward, and then I want to take them from Awkward into Parquet. And what I found that I'm running into is, one way to store sort of a mapping from a tree to the set of branches that you're interested in is to save them in just a Python dictionary. But then dumping that into Parquet was problematic, and I needed to sort of
shouldn't be so hard if you use. Sorry for interrupting you, but that shouldn't be so hard if you use the two arrow, or sorry, 2-arrow functionality in Awkward. It should get the structure correct for you instead of using a Python dictionary.
Okay, I'll explore that then.
Yeah, it wouldn't be a Python dictionary. It would have to be an object. But if they're metadata trees with different breaking down the data in different ways, so that only one of the tree structures is split on events, and another one might be split on something else, that would be possible.
Okay. Yeah, I'll have a go on.
Yeah, they could be absolutely separate. You're at the top top level could be a record. You could have something of length. You could fill a Parquet file with something of length 1. And it's like 5 different things that are all arrays of different quantities. And there are no, I guess what we're talking about here is like in root, you have a mini file system. And that can have several different trees, and all those trees can have the entries mean different things. Whereas a Parquet file is like one tree, one